In this video, we are going to learn about kinematics. We are going to learn about three basic measurement in kinematics, which are displacement, velocity, and acceleration, guys. So let's take a look at the first one, displacement. Before we learn about displacement, we need to learn about position. So imagine that you're going to school at 6 and arrive at 7. At 15, you are going back home and arrive at 16. So to make it simple, let's say your school and your house lies on a straight line. Yeah, to make it simple. And the unit is in kilometer. So let's take a look at what is position. It's very simple. Position is just the location of an object relative to a reference point or origin in a coordinate system. So if you look at my picture here, position of the house relative to the origin. So if I have my origin to be here, and the distance from the origin to your house is 4 kilometer, means that your house is at 4. We say that the position of the house is 4 kilometers. But if your school is at 8, so you write down 8 kilometers relative to the origin. Why we have to say relative to the origin? Because we can place the origin as we like for convenience. So if you put the origin to be here at your house, so it means that I put 0 my house. So that means the position of my house is at the origin or 0 kilometer. But your school will be, if you calculate, this is 1, 2, 3, and 4. So if I move my origin to my house, means that the school's position is at 4 kilometer. And because you can place the origin anywhere, so it's possible if your object is to the left of the origin. So for example, this one, yeah, if you are standing 3 meter or kilometer away from 0, from the left, means that your position is -3. That also works for vertical axis. Let's say you have a bird over here and you choose the 0 or the origin to be here. So that means the position of the bird will be -3. So that is the position, and it's very relative, depends on the origin. Now, if you already understand about the position, now let's discuss about displacement. What is displacement? You have displacement if your object moves from one position to another. It's just the change in position of the object. And no matter where is your origin, the displacement will always be the same. So the formula of the displacement is S equals to x2 minus x1. So x2 is your final position, yeah, while x1 is your initial position, and S is your displacement. And why we use S? Because it comes from the Latin word for space, spatium, yeah. And if you have a vertical motion, it's the same formula, but instead of using x2, I use y2 to represent my final position, and y1 to represent my initial position. Now, let's take a look at the example. The displacement from 6 a.m. to 7 a.m. Yeah, keep in mind the formula is x2 minus x1, final minus initial position. From 6 to 7, initially I'm here at my house, and my final at 7, which is at school. So final position is 8 and initial is 4. So I subtract 8 minus 4, which means I have 4 kilometers for my displacement. But from 5 to 6, from 15 to 16, when I'm going back home, initially I'm here at school, but at 16 in my house. So final minus initial, so 4 minus 8. So it will give you negative. So you will get 4 minus 8, which is minus 4 kilometers. And from 6 to 16, yeah, from 6 to 16, initially I'm here from 6 and 16 I'm also here. So the initial position and the final position are the same. So it's 4 minus 4, which is 0 kilometer. Yeah. From this example, we can learn three things. The first one, displacement can be positive, means that you are moving to the right from your house to your school. So the value is positive. Your displacement can be negative if you are moving to the left from your school to your house. But displacement also can be 0 if your final and initial position doesn't change. No matter how far you go, if you are going back to the same position, the displacement, the total displacement will be 0. Yeah. Nah, because displacement can be positive and negative, and we know that positive and negative represent the direction, like you're moving to the right or to the left. Displacement has both magnitude and direction. Such quantities are called vectors. So vectors is just measurement that has magnitude, how far you go, and direction, you're moving right or left. It's called vector. And vector represented by arrows in diagram. So let's take a look at another example here. Let's say you have a person walks 70 meter east, then 30 meter west. What is the displacement of the person? So if you have a person walk 70 meter east, let's say start from the origin. Remember, we can choose origin anywhere I want. And then it moves 70 meter east to the right. And then it going back, it's going to the west, going west 30 meter. So it's going back. So from 0 to 70, moving is 70 meter and then going back 30 meter. Nah, keep in mind that, once again, displacement only care about initial and final position. Initially, the person here, and the final is here. So to represent the displacement, we can draw an arrow from initial to final. So the red arrow here, this is my displacement. Or I can just write S, and it is 40 meter. Yeah, so your S will be equals to 40 meter. It's positive because the total displacement, you are moving to the right, the total, in total, yeah. Yes, you are moving right and left, but in total, from initial to final, you're moving right. And it's positive, and 40 meter, like how far change from initial to final position. Nah, so as I discussed, we have positive and negative displacement. Positive displacement when you are moving right, for example, from 10 to 30, you're moving right. But if you're moving left, for example, from 50 to 10, you get negative displacement. So for this case, the S will be equals to 20. You subtract final minus initial. And if you're moving up, you also have positive displacement. Yeah. So S will be equals to 60 minus 20, which is 40 meter. Yeah. Nah, but if you're moving left, previous example, final minus initial, so 10 minus 50, which is minus 40 meter. And if you're moving down, you also get negative displacement, 20 minus 60, which is minus 40 meter. So that is the positive and negative displacement. Keep in mind that the reverse convention can be used if convenient. So if you prefer moving right to be negative, you can, but mostly most people just choose right to be positive and moving up because it follows the Cartesian coordinate, guys. Now, we also have distance. Distance is the scalar version of displacement. So what is distance? Distance is just total movement of an object without any regard to direction. Distance does not have direction, it's only magnitude. It's called scalar quantity. So distance doesn't care about direction you're moving right or left. It's just the total movement, how far you go in total. Yeah. So for example, from 6 to 7, the distance. Yeah. So you're moving 4 kilometers away. So you can write down 4 kilometers. And from 15 to 16, you're going back. And we don't really care about moving left or moving right. In total, you are moving 4 kilometers back to your house without any regard of the direction. So it's still 4 kilometers. So in total, you're moving 8 kilometers. Keep in mind that we don't really care about the plus or minus there. Yeah, so that is the distance. And keep in mind that displacement may not equal the distance traveled. As you can see, before my displacement from 6 to 16, it's 0 kilometer, but now it's 8 kilometer. So displacement may not equal to the distance traveled. It can be equal, yeah, if they don't change the direction, the object, but in general may not be equal. Okay, so let's take a look at the checkpoint here, guys. So you have an ant start at x equals to 20 centimeter on a piece of graph paper and walks along the x-axis to minus 20 centimeter. It then turns around and walks back to minus 10 centimeter. Determine the ant's displacement. Nah, remember the displacement, you just care about the final and initial position. Initially, the ant's here, and the final is here. So the displacement will be final minus initial, so that will be minus 10 minus 20. So the ant's displacement is minus 30 centimeter. But the total displacement, the total distance, you don't really care about the plus or minus. It just means how far you go. So the ant starts from 20 and it goes to minus 20. So that means it walks 40 centimeter. And it walks back from minus 20 to minus 10. So if you draw, okay, so it starts from, this is 0, this is 20. So it starts from here, and then it moves to minus 20, and then going back here. So it's moving this way and then go back here. Now, the distance, so from here to here is 40 centimeter and then going back 10 centimeter. So plus 10 centimeter, which is equals to 50 centimeter. So that is displacement and total distance traveled. By knowing displacement and distance, we can define velocity and speed. Now we care about how fast it is changing or how fast it is moving. So we have velocity and speed. What is velocity? Velocity is just how fast the displacement changes over time. So for an object moving at a constant velocity, you can calculate velocity as change in displacement over time taken. Yeah, but if it is non-constant velocity, we can calculate the average velocity instead because it's not constant. And we can calculate the average velocity by using this formula. Net change in displacement over total time taken. Because the velocity is not constant, we just care about the total change in displacement from final to initial. Now, by using this formula, so we can have velocity is v equals to displacement is s over time. So you get s equals to v times t, where s is displacement usually in meter. Velocity in meter per second, we write down as meter s exponent minus 1, and t is the time taken. Keep in mind that velocity is a vector because displacement is a vector as well. While speed, on the other hand, it's the same formula. If you look at the formula, yeah, this is the speed for the constant speed. This is average speed for the non-constant speed. It's the same formula. Instead of using displacement, we are using distance covered. Yeah, so it's the same formula, but speed is a scalar because distance itself is a scalar. So when you divide the distance with time taken, you will get speed. But if you divide displacement with time taken, you'll get velocity. Yeah. So let's take a look at 3 examples here. So a car travels at constant 50 kilometer per hour for 100 kilometer. It then speeds up to 100 kilometer per hour and is driven another 100 kilometer. What is the car's average speed for the 200 kilometer trip? Okay, so as you can see, my car's speed is not constant, so we can calculate average speed instead. Average speed, we can calculate the average speed by defining the total distance traveled over time taken. We know that the total distance traveled is 200 kilometers, so it will be 200 kilometers. But how about the time taken? The time taken will be depend on the speed and the distance. So initially the car traveled at constant 50 kilometers per hour for 100 kilometers. So for the time taken for the first journey, so let's calculate that. The time, if you look at the formula, the time S equals to V times T. So time is just S over V. So the displacement is 100 kilometer over 50. So you get 2 hours. And then for the second speed, speed up to 100 and driven another 100. So for the time when it is moving 100, S over V, but now the S is the same, but the V now speeds up into 100. So you get 1 hour. So the total time taken will be 3 hours. So the average speed will be 200 over 3, the total time taken. So 200 by 3, so you get 67, around 67, yeah. Into significant, you get 67 kilometer per hour. So this is my average speed. Now, for the second question, a cyclist travels at 5 meters per second for 30 seconds, then turns back, traveling at 3 meters per second for 10 seconds. Find her displacement in the original direction of motion from her starting point. So now, because we have two velocity, if you want to find the total displacement, we need to add the displacement. So the total displacement S will be equals to the first displacement S1 when it is moving 5 meters per second plus the displacement when it is moving at 3 meters per second. So the first displacement, the formula is S equals to V times T. So you just multiply 5 times 30 plus the second displacement, be careful, turns back means that it's moving on the opposite direction. So the velocity is not 3 but minus 3 times the time is 10. So you get 150 minus 30. So you get 120 meter. Yeah, so total displacement, just add the individual displacement. And the third example, a cyclist spends some of his journey going downhill at 15 meters per second and the rest of the time going uphill at 5 meters per second. In 1 minute, he travels 540 meters. Find how long he spent going downhill. So, as you can see, cyclists span downhill and uphill. So the total time is 1 minute, yeah, or 60 seconds. So because we want to find the time he spent going downhill, so let's assume that t, yeah, be the time cyclist going downhill. That is the time that we want to find. That means if it is going uphill, the time will be 60 minus t, because total time is 60 minutes, and then t is going downhill. That means the rest, 60 minus t, is just going uphill. Now, and we want to find the time. We know that the total distance is 540 meter. So S equals to V times T. But we have two displacement, one is going uphill and downhill. So the total displacement will be 540 equals to, when it is going downhill, the speed or velocity is 15 times the time is T going downhill, plus when it is going uphill is 5 times the time is 60 minus T. So from here, we can try to solve 540 equals to 15t plus 300 minus 5t. So we get 240 equals to 10t. From here, we get t equals to 24 seconds. That means he spent going downhill like 24 seconds. Now, the last concept that I want to discuss is about acceleration. And we are going to explore more about acceleration later in the next video, but I'm going to explain the basic. What is acceleration? So, what is acceleration? It's just to measure how quickly the velocity is changing. So, velocity is just how fast the displacement is changing over time. But if the velocity itself is changing, like for example, the object like speeds up or slowing down, the velocity is changing, how fast it is changing, we call it as acceleration. So for an object moving at constant acceleration, and we are going to focus on this case, acceleration is just change in velocity over time taken. And because velocity itself is a vector, acceleration also is a vector. So it has direction. Now, the formula of acceleration symbol is A, equals to change in velocity means that we subtract the final minus initial velocity. The final velocity symbol is V. So V is the final velocity in meter per second. Unit of acceleration is meter per second square, or meter s minus 2. U is initial velocity, meter per second, and T is just time taken. Now, because acceleration is a vector, it can be plus or minus, and it will decide whether the object is accelerating or decelerating. So there are two cases for acceleration. When the object is accelerating, means that it speeds up, so the speed is increasing. So for example, in 1 second, your car is moving, U is the initial, from 10 meter per second to 15 meter per second. So your acceleration will be V minus U over time. The V is 15, U is 10, and the time, let's say, is just 1 second. Like it's easy. So the acceleration is 5 meter per second. Yeah. And because A is positive, so the direction of the vector for the acceleration will be to the right because it's positive. So this one is meter per second square. So the acceleration will be 5 meter per second square. But the object also can be moving left and speeding up. So for example, U is minus 5 and V is minus 10. In terms of speed, from 5 to 10, it's moving faster. So if you calculate the A, it's just V minus U over T. The V is minus 10 minus 5, so plus 5 over 1. So you get minus 5 meter per second squared. For this case, because it's moving to the left and speeds up, the acceleration vector is to the left, minus 5 meter per second squared. But if it is slowing down, it's called deceleration. So for example, from 10 to 5, it's slowing down. If you calculate the acceleration for this case, it's minus 5 meter per second square when the time is 1 second. Because it's minus means that the vector is going left because the acceleration is negative. But if your object is slowing down in the negative direction or to the left direction, for example, from minus 5 to minus 1, the acceleration will be positive. If you calculate a equals to v minus u, so minus 1 minus minus 5 plus 5 over 1, so you get 4 meter per second squared. So the acceleration will be positive in this case. Now, as you can see here, whether it's accelerating or decelerating, the value of a can be either plus or minus. And there's some kind of misconception happen, yeah. For deceleration, maybe students think that, oh, it's always negative, but deceleration does not mean that the acceleration is necessarily negative. If we are talking about the positive direction, yes, deceleration is negative, but, well, object can be moving in the negative direction, so the acceleration will be the opposite. So what is the better definition of deceleration? Deceleration when the velocity and acceleration point in opposite direction. So if you look at the case here, when it is speeding up, accelerating, the velocity u and v is going right, and my acceleration also going right. So it's the same direction means that it's accelerating. But when it's u and v is moving left, and my acceleration also to the left, it's also accelerating because it's the same direction. So as long as the velocity and acceleration same direction, it's accelerating. But if it is opposite, for example, this case, moving right, but acceleration negative, it's called decelerating. In the most past paper, we always assume that the object moving in the positive direction, so you will get deceleration negative. So in the case of the object moving in the positive direction, yeah, let's say the object experience acceleration equals to minus 5 meter per second square. Nah, in some problem, be careful with the language, yeah. If you have a is minus 5 meter per second square and the object moving in the positive direction, if the question say deceleration or decelerating, yeah, deceleration, you say deceleration at 5 meter per second square. We don't include the negative because negative already represented by the deceleration here. Negative means moving opposite direction. For this case is deceleration or slowing down. Thank you for watching this video. I hope you learn a lot about the basic stuff about displacement, velocity, and acceleration. And see you in the next video. Thank you.